Hi everyone, my name is Uiwayan and I am a semester 4 diploma student from Polytechnic Tuanku Site Sirajuddin. My supervisor is Serku Muhammad Yusri bin Ko Ibrahim. I would like to share and present my project which named Autonomous Vehicle Using Machine Learning, and here is the picture of my supervisor and me. Careless driving is a prevalent issue that contributes to a significant number of road accidents and fatalities worldwide. To mitigate this risk and enhance road safety, the development of autonomous car using machine learning has emerged as a promising solution. The application of machine learning in autonomous vehicle technology specifically targeted at reducing accidents caused by the careless driving. Autonomous vehicle using machine learning aims to fabricate an autonomous vehicle using Raspberry Pi which will utilize machine learning, deep learning, and neural network to perform various tasks on the road, including detecting signage, avoiding obstacles, and driving on the right track. This project will employ a camera to capture and process data in real time and LiDAR to avoid obstacles on the road. The machine learning algorithm will be optimized by using training mode to improve accuracy and performance. The final system will be designed to operate on a Raspberry Pi 3 platform with the goal of creating a robust and reliable autonomous vehicle that can navigate through complex environments in real time, ensuring safe and efficient travel. By combining machine learning and neural network technique, the project seeks to develop a system that can accurately recognize and respond to dynamic environment on the road. Autonomous car has the potential to revolutionize the way we travel, making transportation safer and more efficient. However, one of the major challenges in developing an autonomous car is ensuring that it can navigate the unpredictable behavior of human drivers on the road. Drivers often ignore signage and engage in risky behavior, putting themselves and others at risk. This problem compounded by the fact that many drivers are careless and distracted when behind the wheel. To address this problem, this project aims to develop an autonomous car using machine learning algorithms that can effectively navigate the road despite the unpredictable behavior of human drivers. The system will be trained on a large dataset of real-world driving scenarios, allowing it to learn from examples of how humans interact with traffic signs, respond to changing driving conditions, and make decisions while driving. By leveraging machine learning techniques such as deep learning and reinforcement learning, we hope to create a system that can accurately predict and respond to human behavior on the road, making driving safe for everyone. The major goal of this project is to create an autonomous vehicle that can use machine learning and autopilot to prevent accidents caused by careless drivers. More specifically, the main goal of this study are to fabricate an autonomous car which can detect signage on the road, to manufacture an autonomous car which can detect obstacles, and to develop an autonomous car which can drive on the right track on the road. This project includes four parts of the whole prototype. The parts are the manual control part, camera part, voltage regulator part, and motor control part. For the manual control part, the receiver of the joystick is connected to Raspberry Pi, then access Raspberry Pi via a Windows PowerShell on the laptop to type the command to use the training mode via joystick. The view of autonomous car can be seen on the website. The camera part is mounted on the autonomous car for image detection when training and autopilot mode. The voltage regulator part uses LM2596 to step down the voltage of the LiPo battery to 5 volt to supply it to Raspberry Pi. The motor part using a differential drive, which is a DC motor for driving and a servo motor for steering. Electronic speed controller connected to a DC motor to control the speed feed to motor, and servo motor connected to PCA9685 to control the movement of steering. The main software used in this project is Python and Anaconda. Based on the flowchart, we can clearly see how the car operates. The car needs to be calibrated first before we run the car. Then we can record the data using joystick or web to record the image for the training purpose. The data then will be transferred to laptop to train the data using deep learning. After finishing training, the data can be sent back to Raspberry Pi to use the data run on the autopilot mode. After the car finishing collecting data, the data will then transfer to laptop and enter the terminal to edit and train the data using Anaconda Pro. The image collect is processed by deep learning for image processing purpose. After finishing collect the data need to be trained on convolutional neural network model, which is deep learning algorithm on laptop due to Raspberry Pi cannot process the image data. The data is trained using graphs on a laptop to process the data so the car can drive by cloning the behavior taught by the user based on the input image. The data trained and then being transferred back to Raspberry Pi to run the autopilot mode. At the end of this project, I hope that this prototype, which name autonomous vehicle using machine learning, will contribute and give benefit to everyone, especially to the country in the field of autonomous vehicle. It's because this project can be developed for hobbyists, researchers, and students with the focus on allowing fast experimental and contributing the community to develop an autonomous car which able to drive safely in autopilot mode, with a little assistance from human. By developing a prototype that is accessible and easy to use, this